In this video, we introduce the Industrial Network example project and demonstrate the load flow calculation. This low-voltage network contains a number of loads and DC and asynchronous motors supplied by two generators and a connection to an external grid. Let's run a load flow calculation. The results can be seen on the single-line diagram, which has been colored to indicate low and high voltage and loading. Let's look in the Network Model Manager. Looking at the lines and sorting by loading, we can see that none of the lines is overloaded. Similarly, all the transformers are within their loading limits. If we look at the bus bars, we can filter to show those where the calculated voltage is more than 5% away from nominal. At one bus bar, the voltage is a little high. As the LV network contains two generators, it would be interesting to see whether the load in the network can be supported if the external grid is not available. In this operation scenario, T1 and T2 off, these two transformers are switched off at the LV side, so there will be no supply from the external grid. We'll activate this scenario and run the load flow calculation again. We now find that the load flow will not converge. If we remove the requirement to consider active and reactive power limits, the load flow will now run, but we see that generator 2 is overloaded. To help understand how the loads in the network are supplied, let's look at the two feeder objects that have been created, one at each generator connection. The feeder definition algorithm determines which parts of the network are fed by which generator. Let's color the network according to these two feeders. The red part of the network is fed from generator 1, and the blue part from generator 2. In order to reduce the load on generator 2, we can reconfigure the network by closing this switch here at bus bar 10 and opening this switch at bus bar 7. This configuration has been set up in this scenario. We run the load flow again with the active and reactive power limits selected once more. The load flow now converges, and no lines or transformers are overloaded. This means that the two generators are able to support the loads in the network as long as it's appropriately configured. Another scenario of interest is whether the network can be supported by the external grid if the two generators are not available. Let's activate another operation scenario to demonstrate this situation. If we run a load flow, we can immediately see from the coloring of the network that the voltages are generally low. This can be seen in more detail in the Network Model Manager. Such a scenario may not be acceptable. Solutions such as reactive power compensation might have to be considered.